Okay, so in this podcast, what I'm going to do is I'm going to show you how to walk through the calculations involving pressure and volume relationships. So hopefully you've already watched the podcast on the relationship between pressure and volume. So remember that pressure and volume are inversely proportional, which means that as one goes up, the other goes down. Now, that is an extremely important fact, and the reason for it is the one of the best parts about gas laws is when you get to the end, your answer has to be checked according to the relationship. So when we set this all up, the thing we'll get to at the end is a double check. And if it doesn't match what we think it's going to be, then we can easily go back and find our mistake. So let's go through this example right now. It says a sample of hydrogen gas is at 1.0 atms and a volume of 22.4 liters, capital L. Now, ATM stands for atmospheres, meaning atmospheric pressure. So that's the pressure of the air that's around you. We're going to get into throughout the course of these different podcasts the different types of units that you may come across. So what pressure would the gas have if the volume dropped to 11.2 liters? Okay, so the pressure started at 22.4 liters and it went down to 11.2 liters. So we can see that the volume went down. Now we know the relationship between pressure and volume is inverse. So if the volume went down, our pressure should go up. So no matter what we get at the end, our answer had better be bigger than what we started with. We're starting with 1 atmosphere, so it should go down. So let's set up a formula that puts a relationship between pressure and volume. Okay, so this is a tiny little formula, and the formula is called Boyle's law, but it's basically pressure versus volume. You do not need to know names of laws in this class. So what you can see here is we have the first pressure, whatever the pressure they gave us first, divided by the second pressure, so P2, is equal to the second volume, V2, over the first volume, V1. Notice how the V's and the P's, the ones and the twos, are opposite to each other. Why? Because we know that pressure and volume are inversely proportional. Okay, so let's keep going. So now what's great about gas laws is basically you're just plugging numbers into formulas. So we've got 4 variables. They gave us 3 numbers. So we're going to plug those numbers into the appropriate locations. Okay, so what I like to do is I like to list them off in the beginning until I get used to the problems, and then later I'll just insert them right into the formula. So my first pressure is 1.0 atm, and that was given, I want to make sure I have my pen on, and that was given right here. Okay, our second piece of information is P2. Now P2 is what I'm going to be solving for. Why? It says what pressure. So that tells me that I'm going to be solving for pressure in this. Okay. Now V1 is the first volume that was given, and that volume V1 goes with the P1. So it says that there's 1 atmosphere and a volume of 22.4 liters. That means my 22.4 is my V1. And then I have my V2, which is the other volume, which would be 11.2 liters. Okay, so as you can see, I have 3 of my 4 variables. I'm just going to plug in them into the formula and solve. Okay, so 1 goes in for P1, 11.2 goes in for V2, 22.4 goes in for V1, and then I'm solving for P2. Now, don't get confused by the units. Okay, if units bother you, just put an X through them. Okay, they are just units. A lot of students get stuck on this stuff, not because of the algebra, because they can't figure out how to punch ATM into their calculator. Remember, they're just units. The number is 1.0. In math class, you guys don't deal with units, so you're not used to it when you come to chemistry. So now what I'm going to do is I'm going to solve. Now, how do I solve? I'm going to multiply. I'm going to cross multiply. So what I called cross multiplying when I was a kid. So basically, I'm going to multiply the top left with the bottom right and the top right with the bottom left. And that's going to get me, and then I'm going to divide by 11.2. Okay? So what I'm going to do is I'm actually going to pull up my handy dandy calculator and plug this in. Okay? So there we go. It didn't want to click. Okay, so now it's on. So I'm going to do 22.4 times 1.0. Okay? Obviously, that was 22.4. I'm only doing it so you guys can see it. Now I divide by the thing connected to the variable. So the 11.2 is connected to the variable. So I go divided by 1.2, enter. So my answer is 2. Exactly 2. Well, since the volume went down by a half, I'd expect my pressure to double, so that kind of makes sense. So now I can see that my answer is 2.0 liters. Now, here's the thing. Before I move any farther, a lot of you guys are going to write an answer, and you have no idea what you're doing. Question yourself. Stop for a second. Does your answer make sense? Well, we know that pressure and volume are opposites. They're inverse, meaning that if one goes up, the other goes down. My pressures went down. My volumes went down. Therefore, my pressures had better go up. I started with 1. I ended with 2. Did the pressure go up? Yes, it did. My answer makes sense. And that's how you solve pressure-volume relationships. If you want to see more examples, go on to the second video that explains the second example involving Boyle's law, or pressure versus volume relationships.